So, okay. So see here, that is the unit number 1. It's a DC circuit. All of you can see this screen, PDF, unit 1 DC circuit.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. In this unit, you are going to simplify the electric circuit. Simplification of electric circuit means what? To find out unknown parameters. Okay. Difficult means complicated electric circuits will be given to you. 1 minute, we'll show you one circuit for example. See it. Like this. Suppose this one. This one electric circuit, all of you can see. See here, this is the voltage source it has. Okay, so see here, if you observe this electric circuit, you can find here, this is the DC voltage source. More than one DC voltage source is there. Okay, there can be DC current source also, and then resistances. Okay, so like this circuits you are going to simplify in this unit. Means it's a combination of resistances and various sources. Which one? DC current source and DC voltage source. See here, this is a symbol. It is used for a DC voltage source. You can use any of these two, either the first one or second one. DC voltage source and DC current source. For DC current source, this is the symbol you can use. Okay, here arrow is upward, means current will start to flow in upward direction. Here arrow direction of this DC current source is downward, means current will flow in this downward direction. Okay, so whatever the circuits you are going to simplify in this unit, it is having DC voltage source, DC current source, only DC voltage source or DC current source or both. Number of sources can be 1, 2 or more than that. And what's about the circuit? This is about the sources. What's about the circuit parameters? Circuit parameters are which one? Resistance, inductor and capacitor. So whatever the circuits you are going to simplify in this unit is only resistances and not the inductor and capacitor. Okay, so like this circuits you are going to simplify in this unit. Means it's a combination of DC voltage source, DC current source and resistances connected in different fashion. Now you are going to simplify this circuits. You are going to analyze this circuits. Means what? You have to find out unknown parameters. Means for example, here see voltage sources, its value is given 100, 50 and 40. Its polarity is also given. Again, resistances, its value is also given 4, 1 and 2 ohm. Okay, so you will get asked find out the current flowing through this resistance or this resistance or this resistance or voltage drop across any of the resistance. This is called as, to find out the unknown parameters, is called as simplification of electric circuit or simplification of electric networks or analysis. Okay, to find out the unknown parameters. So which one methods you are going to use here? Ohm's law, that all of you know how to use Ohm's law. Again, you have to use Kirchhoff's voltage law, Kirchhoff's current law. These three things you have studied in 12th. Ohm's law, Kirchhoff's laws, that is Kirchhoff's voltage law, Kirchhoff's current law, you can use to find out the unknown parameters. Or another method is there which is included in your syllabus is the superposition theorem. Next to it is the Thevenin's theorem and next to it is the Norton's theorem. Okay, so on every topic numericals are included in your syllabus and more weightage is there for numericals in all 4 units. So each and every type of numerical you have to you should be able to solve the numerical using every method. Because specifically they mention simplify it using only superposition, then compulsory you have to use superposition. Okay, you don't have a choice. Compulsory whatever the method given, that one you have to use. So these methods we are going to use in this unit to simplify electric circuits. Okay. Now, so is this clear to everyone? Means like this DC circuit, here sources are DC voltage source, DC current source. That's why
Yes,
it is
ma'am.
called as DC circuit. And only what's about the circuit parameters? Only resistances are there, not inductor and capacitor. Okay, so only resistances will be there. Such types of circuits we are going to simplify. Now, this circuits, which one included? Only linear and not the non-linear. What do you mean by linear? Non-linear means if you are changing the value of voltage, what's about value of resistance? Remains constant. Okay, even if you are changing here some current source you are using, suppose here, and its value you are changing, but still value of resistance remains constant. Okay, we are using here Ohm's law. What is the Ohm's law equation? V is equals to IR. Whenever we use Ohm's law, which one parameter we neglect or which one parameter we assume constant? Temperature. Okay, what we assume whenever I use the equation V is equals to IR, means I assume temperature as constant. Okay, means you are applying here Ohm's law. So temperature you are assuming constant, means it's a linear circuit. That comes under linear circuit. Otherwise, all of you have studied in 12, that is the effect of temperature on resistance of metals. What is it? Suppose resistance along y-axis. Why? Because whenever you plot the graph, dependent parameter always will take along y-axis. Okay, resistance depends on temperature. As temperature changes, value of resistance changes. Means resistance depends on temperature. That's why dependent parameter always you have to take along y-axis. So in 12th, all of you have studied for metals, as temperature increases, resistance increases, isn't it? So, but here we are using Ohm's law. V is equals to IR, means temperature we are going to assume constant, means resistance is also constant. Here in the circuit, you switch it on for half an hour, 5 minutes, as current flows, temperature increases, but what we assume? 4 ohm is constant, 1 ohm is constant, 2 ohm is constant. Means although temperature increasing, resistance we are assuming constant, means we are not considering the effect of temperature. Means temperature is one of the non-linearity. Similarly, friction is also there. Suppose this is the ground, on it you put some body with mass m, apply some force to it. Okay, in this direction you are applying some force to it, then what will be the result? There will be some displacement of this body through some distance, isn't it? So here work we say is being done, but there will be some frictional force, isn't it? And that acts in opposite direction with the movement of this body, isn't it? So this frictional force is there. So this friction is also one of the non-linearity. Temperature, friction, these are the non-linearities. Whenever you are considering these non-linearities and you analyze the system, that its results will be more accurate, and that comes under non-linear analysis. But if you are analyzing the system without neglecting the effect of, or neglecting the effect of temperature, you are neglecting the effect of friction, and you are analyzing the system, then that comes under the linear analysis. Okay, so obviously non-linear analysis, if you do, results will be more accurate compared to linear analysis. Okay, so in this unit you are going to simplify only linear circuits. So what do you mean by linear circuits? Although here temperature increases, means temperature you change, value of voltage you change, current source you change, value of circuit parameters, resistance, inductor, capacitor remains constant, then that comes under linear. But if you are changing temperature or voltage, current in the circuit, and value of circuit parameter changes, then that analysis comes under non-linear. Okay, so linear circuits means Ohm's law you can apply here. All of you have studied in 12th, Ohm's law you can apply only to linear circuits. Okay, so linear circuit you are going to analyze here. Again, bilateral, unilateral. So what is the difference between bilateral and unilateral? All of you have studied in 12th PN junction diode. as a forward bias and reverse bias mode. Diode symbol, all of you know. What I am going to tell you right now, whatever this electric circuit or electric network, it has type. One is linear and non-linear. So linear means what? Suppose temperature, effect of temperature you are going to neglect, linear. Effect of temperature you are going to consider while analyzing the system, while doing calculation, non-linear. So in your syllabus only linear systems are, linear circuits are included. Okay. Second thing is, which one type of circuits we are going to simplify here? Bilateral. What is the meaning of bilateral, unilateral? That I am going to tell you. This one diode, connect across it one DC source. This one you have studied in 12th. This is called as diode in forward bias mode. You can connect diode in reverse bias mode also. What I have done here, anode to positive, cathode to negative. Reverse, if you do, swap the terminals, then that will be diode in reverse bias mode. All of you know diode characteristics in forward and reverse bias mode. Forward bias mode, like this are the characteristics. Reverse bias mode, like this are the characteristics. Okay, means what is happening in both the cases? Current direction is different. Whatever the current direction in forward bias, reverse of it is in reverse bias mode. And with the change in current direction, if the characteristics of circuit changes, then that comes under unilateral. Okay, so diode, if they're in the circuit, with the change in current direction, characteristics of the circuit changes, then that circuit will come under unilateral. In your syllabus, you don't have to analyze unilateral circuit, you have to analyze bilateral circuit. Bilateral circuit means what? Here, see. This one circuit everyone can see. What is it? One DC voltage source it has, one resistance it has. Right now, what is done? This one terminal to positive and this one terminal to negative connected. Now, whatever the VI characteristics you will get here for this current direction, if you swap the terminals, what's about VI characteristics? Will it change or nature of VI characteristics remains constant?
Remains same.
Remains
Constant.
same. Remains same. Means what is the conclusion? Even if I am changing here direction of current flowing through this resistance, characteristics doesn't change. So that comes under bilateral circuit. Got it? Means in this unit, you have to analyze bilateral and linear circuits only. And one more type is there. If sources are there in the circuit, then that comes under active circuit. Okay. If no source is there, only circuit parameters, then passive. Okay. So these are the three types of electric circuit you can see. Got the thing? Linear, non-linear, bilateral, unilateral, active and passive. Okay. So which one you have to analyze? Sources will be there, means active. Only resistances are there, means you can say bilateral, and linear circuits only. We are not going to consider the effect of temperature here. Clear? Okay. So linear, bilateral and active sources you have to simplify in this unit. Okay. Now see here, whenever this is the resistance, I'm going to consider some value R, suppose 5 ohm. This is the voltage source you are connected, consider 10 volt. Now, if you observe here, this one is connected to positive of battery, this one is connected to negative of battery. We don't have to do here anything, what occurs inside the battery. See what is happening outside the battery. Okay, this is the circuit, whatever you can see, it is the circuit outside the battery. What is done? Whatever the battery, two terminals, positive and negative, one is connected to one end of resistance, another to another end of resistance. Now, the moment you switch on this DC voltage source, before it just now I told you, for DC voltage source, you can use either this one or this one symbol. Any of it you can use. Okay. And for a DC current source, If you wanted to show the current in upward, use this one. For downward, this one. Okay, so here value is written 1 ampere, 2 ampere, and this is 10 volt, 5 volt. Okay, whatever is the value. So this is the symbol for DC voltage source. Any of it you can use. This is the symbol for DC current source. Okay, now the moment you switch on this DC voltage source, what happens here? Electrons, what happens with electrons? See, they start to move from negative terminal of battery to positive terminal of battery. In the this one is the external circuit of a battery. Okay, so what happens in external circuit of a battery? These electrons, they move from negative to positive terminal of this battery. This is the flow of electrons. The moment electron starts to move, what we can say, flow of electron is called as current. It is denoted as capital R. Unit is ampere. Okay, milliampere, microampere. Milliampere means into 10 to the power minus 3. Microampere means into 10 to the power minus 6. Okay, so what we can say here, current is flowing in the circuit. So flow of electrons, flow of current. The moment electrons flow, the moment current flow, temperature starts to increase. But here we are neglecting the effect of temperature. Okay, now this is the direction of flow of electrons from negative to positive terminal of battery. What's about current direction in this circuit? So all of you can see here, whatever the current direction, I have denoted as clockwise. Okay, so means what is the conclusion here? Whatever is the current direction, we are going to represent in the circuit. How we are going to represent? If you observe, it is clockwise, means current starts from positive terminal of battery and it moved toward negative terminal of battery. Means you can say here, whatever this conventional direction of flow of current, this is called as conventional direction of flow of current, which starts from positive terminal of battery and it moved toward negative terminal of battery, which is opposite to flow of electrons. Okay, so whenever you are going to analyze the circuit, whenever you are going to find out the unknown parameters by any of the method, Ohm's law, Kirchhoff's laws, superposition, Thevenin's and Norton's theorem, we are going to use conventional direction of flow of current, which is which one? Current always starts from positive terminal of battery and it moved toward negative terminal, which is opposite to flow of electrons. Why it is so? See here, you can compare here both. This is the flow of electrons in the first one circuit, which is in anti-clockwise direction, and conventional direction of flow of current is reverse to it, which is in clockwise direction. Why it is so? Because in earlier days, whenever analysis was done by scientists, what they have assumed first, this one direction, that current flows from higher potential to negative lower potential like this. But later on they discovered that electrons flow like this. That is, they start from negative terminal of battery and they move toward positive terminal of battery. It is the circuit outside the battery. Okay, later on they discovered this one. First one they assumed this and later on they discovered this one. That's why this one is called, whatever is there on your right hand side, it is called as conventional direction of flow of current, which is opposite to flow of electrons. Okay, so we will use, whenever we use to find out unknown parameters, we will use this one only, which is opposite to flow of electrons. And you can use this one also. You can use this one also. In both the cases, whatever your magnitude of current or voltage drop you are going to find, or any unknown parameter you find, its magnitude will be same, isn't it? Okay, so it don't affect whether you are using this one direction or this one direction for analysis of the circuit, but we'll use conventional because in every book this one only is used while analyzing the circuit. But you can use this one also. Okay, magnitude of voltage or current will be same with this. Okay, only signs will be different then. Okay. Ohm's law, V is equals to IR. Just now I told you here to this circuit you can apply Ohm's law. See, voltage source of 10 volt, a resistance of 5 ampere. So Ohm's law you can apply here because it's a linear circuit. Ohm's law is applied to MCQ question, linear circuit, non-linear circuit, or both, linear, non-linear. So which one is correct option? Linear. Okay, so two linear circuits, you can apply Ohm's law. Ohm's law equation V is equal to IR, temperature we assume constant. So if you apply here, what will be the current value? You will get 2 ampere. Okay, so 2 ampere current will flow here. A resistance we are going to assume constant 5 ohm. Means Ohm's law you are applied. Temperature you are going to neglect. Okay, now see here 1 ohm resistance, 2 ohm resistance and 3 ohm resistance, R1, R2 and R3. Resistance, it is the whenever electrons flow through the circuit, some opposition will be there to the flow of electrons, which is called as resistance. It is denoted by capital R. Unit is ohm. This one you already have studied in 12th. Okay, so R1, R2, R3, these are the three resistances connected in series. Now see here, I'm going to tell the concept of when the resistances are said to be in series and in parallel, because whatever the difficult networks sometimes given to you to analyze, sometimes students can't identify correctly whether the resistances are connected in series or in parallel. So everyone apply this concept. See, all of you can see here, this is the 12 volt DC voltage source, R1, R2, R3, 1 ohm, 2 ohm and 3 ohm. Three resistances are connected in series here. Now, the moment you switch on this voltage, what is happening? Conventional direction of flow of current I will use. That is the current, it starts from positive terminal and it moves to negative terminal. Now you can observe whatever the current flowing through R1, same current is flowing through R2. And same current is flowing through R3 also. If like this you observe in electric circuit, then you can say R1, R2 and R3 are connected in series. Just trace the current direction. If same current is flowing, then only you can say the resistances are connected in series. Means what is the conclusion? When the resistances are connected in series, same current flows through them. Okay, so in that case, if you get asked to find out the equivalent resistance, what you can do? You can add them. 1 ohm, 2 ohm and 3 ohm. So total resistance, you can denote it as R total or you can denote it as R equivalent also. Okay, R equivalent. I know some students have studied this concept, but still directly I can't go for superposition, Thevenin's or Kirchhoff's. I have to revise this concept. Okay, when the resistances are said to be in series, in parallel, same current flows, what's about voltage drop? Okay, so listen it, although you have studied it in 12. I already told you 1 hour part, you already have covered, but not later on. Okay. So total equivalent resistance you can denote as RT or R suffix equivalent. So 6 ohm total equivalent resistance, and then you can find out the total current using the Ohm's law. Total voltage 12, total resistance we got 6, so 2 ampere is the current flowing. And if you get asked to find out voltage drop for 1 mark, 1 mark like this, 3 resistances connected in series or in parallel, find out the current flowing through each or voltage drop across each or R equivalent or total current. Like this questions for 1 mark. Okay. For MCQ exam, you may get, you will get asked. Okay. So here, total current we got. So using that, you can find out the voltage drop across each. So how much will be the voltage drop across first one resistance? Here see, 2 ampere is the current flowing through this. Now 2 into 1, so 2 volt will be across this. 2 into 2, that is the 4 volt will be across this. So the rest, that is 2 plus 4 is what? 6. So 12 minus 6, the rest 6 will be across the third one. Hence here, what is the conclusion? First thing, whatever the circuit given to you, first observe whether the same current is flowing or not. If same current is flowing, then you can say the resistances are connected in series. If they are connected in series, how to find out equivalent? Add them. You will get its equivalent. Okay. Then once you know total current, you can find out here a voltage drop across each resistance. Okay. So here, if you observe, as same current is flowing, this one parameter is same. More the resistance, more is the voltage drop across that resistance when the resistances are said to be connected in series. So when the resistances are said to be connected in series, more the value of resistance, more will be the voltage drop across it. Which one of the following statement is true? 2, 3 statement given. So more is the for series connected resistances. More is the value of resistance. More will be the voltage drop across it. So series connected resistance is clear. Now we'll see about the, and here all of you know V1 plus V2 plus V3 will be the total applied voltage. It is nothing but KVL. How to apply KVL we'll see in detail also soon. Okay, then when the resistances are said to be connected in parallel. Here everyone check the two conditions. Now see here, voltage is 24 volt. Again it's a linear bilateral circuit only. Linear bilateral circuit it is. Because DC voltage source is connected and only resistances are there. So 24 volt DC voltage source 4 ohm and 6 ohm are connected in parallel. Okay. Now see here, across A and B, 4 and 6 ohm are connected in parallel. So two conditions you have to check. If you observe here, see, conventional direction of current I will use will start from positive terminal of battery and it move toward negative terminal. Now, once this current reaches at node A, junction A, point A, what is happening? It has two paths. Some current will flow through 4 ohm and the rest will flow through 6 ohm. Okay. And again at point B, what is happening? Same amount of current I leave and that reaches to negative terminal of battery. So when the resistances are said to be connected in parallel across A and B, what the first one condition you check? Whatever the current entering at node A, same current and same amount of current must leave node B. This is the first condition. Second one you have to check, that is I suffix A, I suffix B. These two currents are equal to I1 plus I2. Okay, it is nothing but it's a KCL. I is equals to I1 plus I2. We'll see soon KCL also. You already have studied it in 12. These two conditions you please check. Okay, which one two conditions you have to check? Is this clear to everyone? The first one condition, whatever the current entering at node A is same current and same amount of current leaving the node B. Those who want to score, again I am repeating each and every point, you have to listen carefully. You will definitely score in this subject. Okay.
Yes.
So
Yes.
IA is equals to IB. This one subject is difficult, numericals, but if you listen each and everything, you will find it easy. You don't have to spend separate time to understand the things from to read and to understand it from book, because understanding it is done only in the lectures. Then later on you have to read and only practice. Okay, so this is the those who want to save the time, your time, please listen lecture. Okay, and those who want to spend more then and score less, obviously those who don't listen, their score will be less and they have to spend more time on studying. Okay, so I and IB, this is the first condition, and the second condition you please check, I1 plus I2 is equals to IA is equal to IB. Okay, these two conditions you check. Whenever while solving any circuit, if you feel that, or if you think that the two resistances are in parallel, check these two conditions. Which one? See, mark the nodes or point across which they are connected in parallel and check whatever the current entering at node A, same must be the leaving node B. First one condition, I is equals to IB, and check whatever these two resistances you think or you feel that are in parallel, so current flowing through them I1 plus I2 is equal to IA is equal to IB. Check these two conditions. Okay, if both conditions get satisfied, then only you can say the resistances are in parallel, otherwise not. Okay, got it? Okay, got the two conditions, everyone? Okay, so here this one all of you know, I is equals to I1 plus I2. It is nothing but it's a KCL. Now here 4 and 6 are both the conditions get satisfied. So what I can say, 4 ohm and 6 ohm are connected in parallel across node A and B. So when the resistances are connected in parallel, how to find out their equivalent? Use this formula. 1 by R equivalent or 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. This is the in general formula. Okay. for more okay, connected in parallel. If only two are there, you can do R1 into R2 divided by R1 plus R2. Only for two you can use this one, okay, otherwise this one. 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on to find out equivalent resistance. Now if both the resistances are connected in parallel, all of you know, you connect one voltmeter, you take one voltmeter, connect it across this 4 ohm, take one voltmeter and connect it across 4 ohm, two terminals. What will be its reading? You will find it 24 volt. Same thing you will do, 1 voltmeter you connect across 6 ohm, you will find its reading is 24 volt. Means what is the conclusion? When the two resistances are, or any number of resistances are connected in parallel, voltage drop across parallel connected resistances is same. But what's about current? You can see different current will flow. More the value of resistance, lesser current will flow through it. Which of the following statement is true? 2-3 options given. When the resistances are connected in parallel, voltage drop across them is same. Okay, more the value of resistance, less current will flow through that. Like these are the options, isn't it?
Yes, ma'am.
So see here, voltage drop across each is same 24 volt, and so using that resistance, you know, so 24 by 4, 6 ampere current will flow through R1, and 24 by 6, that is 4 ampere current will flow through R2. So you got current flowing through R1 and R2, you can add them, you will get the total current 10 ampere. For 1 mark, 1 mark like this questions you will get asked. Simple circuit will be given to you, anything they will ask you, find out R equivalent or total current or current flowing through 4 ohm or current flowing through 6 ohm or voltage drop across 4 ohm, voltage drop across 6 ohm. Clear? Okay,
Yes, ma'am.
like this questions
Yes,
for
ma'am.
1 mark. Is it becoming fast? If my speed
No,
is
ma'am.
my speed is
No,
fast,
ma'am.
please tell me, I'll slow it down. Okay. So one more thing, see, this is the method you have used here to find out the current. One more thing is there, current division rule. So I think current division rule you have not studied in 12th. When you can apply current division rule, first thing is the resistances must be in parallel. Secondly, only two resistances. Okay, so when you can apply current division rule, when two resistances are connected in parallel. So here 4 and 6 are in parallel and only 2 are there. So you can apply here current division rule. So what it says, current division rule, see here. Here total voltage, you know, 24 volt. Total resistance we got 4 and 6 are in parallel. So 24 by 10 you will get. And using that total voltage divided by total resistance, you can find out total current 10. Now you got what I am telling to you, how to apply current division. Okay, so here see, for that what is required? Two resistances connected in parallel, their value you should know. So 4 and 6 it is given. Total current entering at their parallel junction or leaving, same it is, that also you should know. And that's ye dekho 10 ampere, here we have calculated 10 ampere. Okay, so current division rule you can apply here to find out current flowing through R1 and to find out current flowing through R2, I1 and I2. Okay, so what is it formula? See, this one is the formula. What is I1 is equals to I total. This I total is which one? This one, which enters at node A and which leaves node B. Now I1 is the current flowing through which resistance? Yes, I1 is the current flowing through which resistance?
4 ohm.
R1.
R1.
4 ohm. Right, R1, that is 4 ohm. Parallel to it is which resistance?
R2.
R2. That you
R2.
have to take it in numerator. Clear? Ye formula? Don't do here mistake. Here most of the students
Yes,
take
ma'am.
R1 and then their answer becomes wrong. Okay, so here be careful students. Again I am repeating, whenever you wanted to find out I1, so I1 is flowing through R1, parallel to R1 is R2, and that one you have to take here in numerator, divided by addition of two parallel resistances. Okay, got it? So this is the formula. I1 is total current, parallel resistance divided by addition of two parallel connected resistances. Okay. Similarly, same is the formula for I2. You have to apply. Now I2 is equal to what? Total current. Now in numerator, which one resistance you will consider? For I2, R1. Got it? Don't do
R1.
here only mistake. Here only student does the mistake. So don't do it. Okay. And divided by same. ये देखो, ये जो parameter है ना, वो same ही है दोनों तरफ. ठीक है? Okay. I total and in the denominator R1 plus R2. That parameter is same. Only whenever you wanted to find out I1, so it is flowing through R1. Parallel to it is R2. Same is the thing for I2. Okay. So using this also you can find out current flowing through each resistance. Means this is sometimes it becomes easy to find out the current flowing through resistance if you apply current division. Okay. So it depends on numerical, whether sometimes it becomes easy to solve when you apply Kirchhoff, sometimes superposition, sometimes Thevenin, sometimes Norton's. Okay. So whatever is easy that you can apply when you do the analysis, but in exam you don't have any choice. Compulsory, they whatever the method they mention, that only you have to use. Okay. Here 6 ampere and 4 ampere, same answers. Earlier one also, see 6 and 4, same answer we got. Okay, means here this one is the thing, means how to apply current division. Okay, so current division rule when you can apply, when the two resistances are connected in parallel, applying it, you can find out the current flowing through each resistance. If 3 are there, then what you will do? If 3 are there, then what you do? Any two you find out its equivalent. Suppose R1, R2 and R3 are there, and still you are interested in applying current division rule here. Then what you can do? ये जो second और third है ना, इसका equivalent find out कर दो. Suppose ये 2 ohm है और ये भी 2 ohm है, तो दोनों का equivalent कितना होगा? 1 ohm, isn't it? 1 ohm होगा और ये 3 ohm है. So इसका equivalent circuit क्या आएगा फिर? This is the 3 ohm, parallel to it is 1 ohm. Got the thing? What I am saying? Everyone got it? Yes?
Yes.
Huh?
Yes.
Huh. Means when you can apply current division rule, when only 2 are there. But if 3 are there and still you are interested in applying current division rule, what you can do? This 2 and 2 ohm, see, this is 2, this is 2. So its equivalent is 1 ohm. So that I have represented here 1 ohm, and this 3 ohm as it is. See, 3 ohm. Now here 3 ohm and 1 ohm are in parallel. You can apply current division rule and find out the current. Okay. Once you get current flowing through 1 ohm, then you can find out through this also, to 2 ohm. Isn't it? Like this.
Yes, ma'am.
So current division rule. What is important thing is here, if required, you should be able to apply current division rule to find out the current. That is the application of it. Okay, current division rule. Or once you get this I1 6 ampere and this I total you know 10. So 10 minus 6 is 4 ohm. So no need to apply current division rule to find out I2, isn't it? But you can. सेम आंसर यू विल गेट. ठीक है. सो यहाँ पे आप डायरेक्टली 10 minus 6 4 कर सकते हो. नो नीड टू गो फॉर दिस स्टेप. मींस लेस टाइम इट विल टेक. ओके, नेक्स्ट. सो वोल्टेज डिवीजन रूल. Voltage division rule, see current division rule, I told you two resistances connected in parallel. Similarly, voltage division rule, two resistances connected in series only. Okay. If the resistances are in parallel, then voltage drop is same, that we have seen just. Means we'll again come back to this parallel connected resistances. Means what is the conclusion here? First thing, when the resistances are said to be connected in parallel, when total current entering at node A same is the current leaving at node B, means I suffix A is equals to I suffix B. First condition. What is the second condition? This I1 plus I2 is equal to IA is equal to IB. If these two conditions get satisfied, then you can say here 4 ohm and 6 ohm are connected in parallel. Check these two conditions. First thing. What's about the second thing? We have seen when the resistances are connected in parallel, voltage drop across them is same. Here voltage across 4 ohm and 6 ohm both is 24 volt. Then when the resistances are connected in parallel, you can use this formula to find out its equivalent. 1 by R equivalent or 1 by R total is equals to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Okay. And current division rule you can apply to two resistances connected in parallel. Okay. What is the formula? Just now I told you, keep this in your mind. Okay. Similarly, for series connected resistances, we have seen that the same current flows, and how we find out its R equivalent, R1 plus R2 plus R3 and so on. Here you can apply voltage division rule. Okay. So voltage division rule is what? See, suppose I wanted to find out voltage across this 6 ohm. So what is the formula? V1 is equals to total voltage, that is this 20 volt in numerator. Now here is the thing. For current division rule, we used to take parallel resistance. But in voltage division rule, same resistance you have to consider in numerator. See, V1 is the voltage drop across which resistance?
R1.
R1. So same you have to take here. Got it? And otherwise then the formula is same. Here V total and R1 plus R2. Same for V2. Okay, V2 is equals to V2 is the voltage drop across what? R2. So that you have to
R2.
take in numerator. Clear? Voltage division rule formula is clear to everyone? So
Yes, ma'am.
voltage division rule,
Yes.
you can apply it to again the same thing. Voltage division rule, whenever you wanted to apply, you can apply it only for two resistances connected in series. If more than two are there, then any two you add, and means two resistances you will get. If three are there, and then you can apply it. Okay, so clear voltage division rule formula. So see here, voltage, total voltage 20 values you put 6 ohm, 4 ohm, so you will get 12 and 8 volt. Okay, so this is about the voltage division rule. Voltage in, see, sometimes in circuits what they give, this is the first one voltage source in series with its second one voltage source, so its equivalent you can represent. Now if you observe, see, this is 10 volt, second one is 5 volt. If you observe, its polarity is same. Same means what? Upper one for both, upper one is positive and lower one is negative. For this also, upper one is positive, lower one is negative. So its resultant also will have the same polarity, upper one positive and lower one negative. And whenever the sequence is same, that is upper one is positive and lower one is negative for 2 in series, 3 in series, 4 in series, then add them. So 10 plus 5, 15 volt. Got it? Or you can say the alternate. See, plus, minus, alternate. So add, you can add it. So 15 volt will be its equivalent. Okay. See here now, second condition. See, for 2 volt, what is done? Upper one is negative, lower one is positive. For this also same. Upper one is negative, lower one is positive. Whatever its equivalent also same. Upper one negative and then lower one will be positive. Here also obviously you have to add. Why? Because same it is. That is upper one negative, lower one positive for both. Or you can say alternate. See, minus plus minus. So what will be its equivalent? 10 plus 2, 12 volt. Okay, got it? Any difficulty with this?
मैम एक्चुअली आई हैव डाउट
Yes, please.
वोल्टेज डिवाइडर सर्किट में करंट कैसे फाइंड आउट करेंगे हम?
ओहम्स लॉ यूज कर सकते हो आप. ये देखो, ये जो है,
V is equal to IR, no?
yes, see,
R1
yes,
plus R2.
right, 6 and 4 are in series, so total will be 10. Okay, 10 ohm and 20 volt divided by 10 ohm, so how much? 2 ampere. 2 ampere current will flow. Got it? This one is simple. Whatever the circuits I have taken right now to explain you concept are simple. Whatever you have to solve complicated circuits. First of all, with the help of simple circuits, we'll explain the concept, and then you can go for complicated circuits. Okay, clear?
Yes, ma'am.
So,
Yes, ma'am.
yes, please.